Myself, Dr. BJD Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss about cache memory. So, here at the end of this video, the student will understand what is a cache memory, for what purpose the cache memory is needed, and what are the principles upon which the cache memory can operate, what are the various memory mapping strategies, what are the writing policies of the cache can be discussed. So the basic agenda of this video is the introduction, cache memory, mapping techniques and the writing process are the policies of the cache memory. So memory unit is basically used for storing user programs and data. The programs can be stored from the secondary storage, can be brought into the main memory for the execution by the CPU. So a memory is collection of storage sets together with associated circuits needed to transfer information in and out of the storage. The memory stores binary information in groups of bits called the words. The internal structure of memory unit is separated by number of words it contains and the number of bits in each word. So the storage capacity can be decided with the address space, and here how many bits can be collected to represent a word can determine the storage capacity of the memory. So two registers are majorly used to access the memory. Basically, two operations can be performed on the memory unit. That is either read operation or the write operation. During read operation, the content of the memory can be retrieved and that data is stored in the MDR register. From which location of the memory it has to retrieve the data can be directed by the address that is stored in the MAR register. While performing the write operation, the data that is available in the MDR register can be transferred to the memory location that is pointed with the address stored in the MAR register. So, processor and memory can be connected with the address bus, data bus and control bus. The address bus, how many number of bits are present in the address bus? For example, consider if there are k bits, 2 power k is the address space of the memory. If there are n bits of the data bus, the width of the data bus is n bits, there should be n number of bits to be represented as one word. So the word length is equal to n bits. So which operation is to be performed on the memory can be directed by the control signals that are raised by the control unit. The read operation can be performed when the capital R signal, control signal is received. W, write operation. MFC for memory function complete, either to indicate or to acknowledge the completion of the read and write operation. The MFC control signal can be used. So these are the control bus structure and the registers required to perform the read and write operations on the memory. Now we will discuss what are the various types of memory. So here basically the memory can be categorized into primary memory and secondary memory. Primary memory can be either cache memory or the RAM or the ROM. So the cache memory is comes under the category of primary memory, and the RAM and ROM are other two categories of the primary memory. So the RAM and the cache memory are volatile in nature. That means the whatever data that is stored in the memory can get erased if the power interruption occurs or when the user switched off the computer. But main memory ROM and the secondary memory are the non-volatile in nature. So in the RAM and the cache, the user can able to perform both the read operation as well as write operation. And here in the main memory, the another part is non-volatile, that is the ROM memory. In the ROM only the user can perform read operation, and write operation can be performed with the special signals of ultraviolet rays or electrical signals. So based on this, the ROM can be categorized as PROM, EEPROM, E-square PROM. And the secondary storage devices can be categorized into magnetic tape, magnetic disk, optical disk, and flash memories. All these categories we discussed in the previous videos. Now in this video, we majorly focused on the cache memory. What is the organization structure of the cache memory, how the information can be transferred from main memory to cache memory with the various memory mapping techniques, how write policies can be implemented in the cache memory. So how these various categories of memory devices can be connected with the central processing unit. So this is the central processing unit and this is the main memory. In between CPU and main memory, the cache memory can be connected. It is a small high-speed memory that is connected in between CPU and the main memory. And the secondary or the auxiliary memory devices, magnetic tape and magnetic disk, can be connected to the memory with the help of I/O processor. So in this way, the primary memory, the secondary memory and cache memory are connected to the CPU. What is the hierarchy of the various devices? So CPU registers can have the fastest or high speed access devices. Why? Because they are available on the CPU processor itself and can contain the operand data readily available for the ALU. Next level is the cache can be filled, and here 3 levels of caches can be generally implemented. That those levels can be represented with L1, L2 and L3. Next, the main memory, later on the secondary memory. So the speed of accessing has to be increased while traversing from bottom to top, and cost per bit can be reduced while traversing from top to bottom. So memory hierarchy is to obtain highest possible access speed while minimizing the total cost of the memory system. So the access time increases with the distance from CPU. Cache is very near to the CPU, so the speed of accessing can be high in case of cache memory. The cost per bit is decreases with the distance from CPU. Now, what is cache memory? A cache is a small and very fast temporary storage memory. So, the size of the cache is very small, but the speed or accessing mechanism can be very fast in case of cache memory. It is designed to speed up the transfer of data and instructions. It is located inside or close to the CPU chip so that the speed of access can be high. It is faster than RAM, and the data instructions that are most recently or most frequently used by CPU are stored in the cache. In a program, the program can be a collection of instructions. So in this collection, there is varieties of instructions are available. Simple instructions, control structures, looping structures, functions, exception handling mechanisms. All instructions can be composed by the user in order to perform a specific task with the help of the program. But in the looping structures, the loops can be generally used to repetitively execute certain block of instructions. So these instruction set can be accessed by the memory very frequently. Those frequently accessed instructions can be generally bring from main memory to the cache, and there it can store in the cache, so that the CPU, whenever required to access these instructions, first look into the cache whether these instructions are available in the cache or not. If at all they are available, so that they can be retrieved and quickly it can execute the program. If at all they are not found in the cache, then it will go and look into the main memory in order to access the demanded instructions. The cache memory is placed in between the CPU and the main memory. The cache is a fastest component in the memory hierarchy and approaches the speed of CPU component. Access time to cache memory is less compared to main memory. It contains a copy or portion of the main memory. So the frequently accessed instructions can be copied from main memory to the cache. Cache bridges the speed mismatch between the processor and the main memory. The synchronization of speed between CPU and main memory can be done with the help of cache memory. So how the cache can be located means this is the main memory and CPU. In between the cache memory can be placed, and the frequently accessed instructions or data by the CPU can be bought from main memory and can be copied to the cache memory, so that the CPU can first look and for these instructions in the cache memory. If at all they are available in the cache memory, it can access them and execute very quickly. If at all they are not available in the cache memory, then only the CPU will go and look into the main memory whether these instructions are available in the main memory. Okay, so here the unit of data transfer between the main memory to cache is in terms of block. So block transfer can be taken place between main memory and cache, and between cache to CPU, word transfer, the unit of transfer is word. So here the block has to be moved from main memory to cache. From there the word can be moved to the CPU. How this block can be mapped to the word is with the help of cache mapping techniques. What is the need for cache? The data and instructions are retrieved from RAM when CPU uses them for the first time. A copy of the data or instructions is stored in the cache. So they need to transfer from the main memory to the cache memory with the help of the block. The next time the CPU needs the data or instruction, it first looks into the cache. The search for the required data or instruction is first in the cache memory by the CPU. If the required data is found there, it is retrieved from cache memory instead of the main memory. It speeds up the working of the CPU so that the instructions can be readily available for the CPU for execution. What are the types or levels of cache? A computer can have several different levels of cache memory. The level number represents distance from the CPU, where level 1 is the closest one. So the level number can indicate that how far it is from CPU. All levels of cache memory is faster than the RAM. The cache closest to the CPU is always faster, but generally costs more and stores less data than other levels of cache. So the level of cache that is very near to the CPU can be the fastest one. All levels of cache can be fastest rather than the RAM. but the cost of these cache memory is high when compared to the RAM. But these are having less storage capacity when compared to the RAM. So here three levels of cache can be established. So this is the CPU and this is the L1 cache, which is very close to the CPU, and this is the fastest among the remaining caches. But the size and cost of this L1 cache is high. Next level is L2. L2 cache is in between the L1 and L3 cache, and this is somewhat less speed than the L2 but more speed than the L3. Next level is L3 cache. Next is main memory. So L1 cache, it is also called primary or internal cache. It is built directly into the processor chip. It is of small capacity. Up to 120 kilobytes of data can be generally stored in the L1 cache. It is very close to the CPU. The next level is L2 cache. It is slower than the L1 cache. Its storage capacity is more, from 64 KB to 16 MB. When compared to the L1, L2 cache can have the more storage capacity, but the speed can be low when compared to the L1 cache. The current processor contains advanced transfer cache on processor chip, that is on the type of L2 cache. The next level of cache is L3 cache. This cache is separate from processor chip on the motherboard. It exists on the computer that uses L2 advanced transfer cache. It is slower than L1 and L2. The personal computer generally L3 cache is up to 8 MB of storage capacity. So like this, the three levels of cache can be accomplished. These three levels of cache can be either accessed simultaneously or hierarchically. So in case of simultaneous access, all the levels of cache can be connected directly to the CPU. So parallelly, the instructions stored in the cache memory is accessed simultaneously, so that the speed of the execution of the program can be increased, which in turn increases the performance and throughput of the system. Next, two operations are generally performed on the cache. One is hit, the second one is miss. What is cache hit? A cache hit is when an application needs data and finds that data in the cache, so it never has to take the slower route and read the disk. So here generally the needed data for the CPU can be accessed from the primary memory. If at all it is available in the secondary memory, it can first transfer to the primary memory. Thereby, from there it can access by the CPU and start the execution. But if at all some most frequently used instructions can be transferred from main memory to cache memory. A copy of some main memory part can be maintained in the cache memory. If the required instruction is available in the cache memory, the CPU first look into this cache memory for that instruction. If at all that instruction is found, a match can be occurred here. That operation is called the hit operation. So it no need to it eliminates the CPU, the secondary search in the main memory, which is a very slow accessing of data or instruction. So what is the hit ratio means? Total number of cache hits or requests by total number of cache hits plus total number of cache misses is generally considered as cache hit ratio. Now we have to discuss about what is cache miss. A cache miss is when an application needs data that does not find in the cache, so then it has to go and find the data on the disk. So first here the CPU can first attempt to check whether the data is available in the cache or not. If at all it is found, then it is a cache hit. No need to search for in the main memory. If it all not found, then it is a cache miss. So the CPU has to go and check in the main memory for the required instruction or data. So that is the cache miss. Cache can be worked on the principle of locality. So programs tend to reuse data and instructions near those they are used recently or that they are recently referred themselves. So these frequently accessed instructions that are very near to or referenced frequently themselves can has to be stored in the cache. So thereby the cache can work on the principle of locality. So the locality can be temporal locality or the spatial locality. Temporal locality means recently referenced items are likely to be referenced in the near future. And spatial locality means items with nearby addresses tend to be referenced close together in time. For example, consider a looping structure in the program. A for loop, in this, it has to run from 1 to n, and here in the loop it can has to sum the values. So a variable sum can be used which has to be used to add the previous sum value. So here the loop variable I can be referenced there itself, and the sum can has to be added with the next incoming value. So the s variable can come under the temporal locality, and the I variable can be referenced as a spatial locality. So these instructions are very frequently used so that these instructions can be placed from main memory to the cache memory. So here a cache mapping technique can be needed. The data can be transferred from main memory to the cache memory in terms of block transfer, and the cache memory to the CPU, the data can be transferred with the word transfer. How these block can be mapped with the word? So this can be achieved with the help of cache mapping technique. So here cache mapping is a technique by which the contents of main memory are brought into the cache memory. In cache memory, data is transferred as a block from main memory to cache memory. So this block has to be mapped with the word transfer. This process is known as cache mapping. So there are three types of mapping techniques are available. One is direct mapping, associative mapping, and set associative mapping. What is direct mapping? A particular block of main memory can map only to a particular line of a cache. So the line number of the cache can be recognized with the help of cache line number is equal to main memory block address modulus of number of lines in the cache. So with this help of this, the line of the cache can be identified, which can be the target location from the main memory. The specific line number can be identified to move on to the copy of the instruction. So here the physical address can be used to specify the tag and the line number. Both can be referred as the block number. Next, block or line offset can be used as the physical address. So here in the memory, all the data can be divided and organized as the block, and in the cache these can be line numbers and the specific tags can be placed. So here with the help of the formula, the J mod n can be used in order to find the mapping of which location of cache can be used for the transfer of this memory block. So here this is the match. So the block 1, the block J can has to be transferred from main memory to this in the cache memory. The next one is associative mapping. A block of main memory can map to any line of the cache that is freely available at that moment. Here, no need to use the modulus calculations, where the freely available location is identified. There, the memory block can be moved. This makes fully associative mapping more flexible than the direct mapping. All lines of cache are freely available, thus any block of main memory can map to any line of the cache. So, had all the cache lines have been occupied, then one of the existing block will have to be replaced with the replacement algorithms. So here these are the main memory blocks, and there is a free space available in the cache. To that particular freely available lines, this block can be mapped. So here the physical address can have block number or tag, block or line offset. The third mapping technique is set associative mapping. Set associative mapping combines direct mapping with fully associative mapping by arrangement of lines of a cache into sets. The sets are persistent using a direct mapping scheme. So, set associative mapping is a combination of direct mapping and the associative mapping. However, the lines within each set are treated as a small fully associated cache, where any block that can save in the set can be stored to any line inside the set. So in the set associative mapping allows that each word that present in the cache can have 2 or more words in the main memory for the same index addresses. So in this way the sets can has to be maintained. So here, so these are having the same indexing between these. So these are grouped as a set 0, and here the cache is has to use the modulus here in order to find the trace the line number and to refer the in that set the specific tag, so that the physical address of the set associative mapping can have the fields of the tag, index and the offset. The word offset is used to identify which word of the block the user want to access. So the block from the main memory the user want to access can be specified with the word offset. The set number is used to identify which block in the main memory is mapped to which set in the cache. So here this can has to be used to identify the particular set of the cache with respect to the main memory. The tag is used to uniquely identify each block in the set. So here set is a collection, in that the tag can be used to trace a unique value. So calculate the number of tag bits by simply subtracting word offset and set number bits from the main memory bits. In this way, the set associative mapping can be used for the cache memory mapping. What is the comparison between direct mapping, associative mapping and set associative mapping? In the direct mapping is the simplest mapping technique. Map each block of main memory into only one position of cache line, which can be calculated with the help of modulus operation. In case of associative mapping, permits each main memory block to loaded into any line of the cache that is freely available. The cache control logic interprets a memory address simply as a tag and a word field. So only two fields are required for the mapping for the physical address in this type of the cache mapping technique. To determine whether a block in the cache control logic must simultaneously examine every line of the tag for a match. The third category is set associative mapping, a compromise that exhibits the strength of both the direct and associative approaches while reducing their disadvantages is the set associative mapping. So these are the three cache mapping technique. So in case of any pages has to be removed from the cache, then replacement algorithms can be used. The popularly used page replacement algorithms are FIFO and LRU. FIFO means first in, first out. The oldest item or the oldest page that is available in the cache can be replaced with the latest item. In case of LRU, least recently used, when the page which is least recently used by the CPU, that can be removed and can be replaced with the latest page in the cache. So these are the page replacement algorithms that can be used. Now what are the cache writing policies? Whenever a processor wants to write a word, it has to first to see the address it went to write the data to is present in the cache or not. If the address is present in the cache, then it is a write hit. In case of write hit, the cache can use two policies to write the data onto the cache. The two policies are write through and write back. These two policies are majorly used to avoid the data inconsistency problem. Why? Because main memory, copy of main memory content, part of the main memory content can be available in the cache. So, to avoid the data inconsistency problem, two write policies can be used by the cache. They are write through and write back. What is write through? Data is simultaneously updated to cache and main memory. So parallelly, the data can be written in the cache as well as main memory. For example, these are the previous states of cache and main memory, and when data write hit is occurred, then with the write through, this new data can be written parallelly in the main memory as well as in the cache. The second policy is write back policy. The data is updated only in the cache and updated to the main memory at a later time. So first cache can be updated and main memory can be updated later. For example, consider this is the state of the cache and main memory. The new data can be written into the cache, but at a later, the main memory can be updated. So this is referred as write back policy. These two policies can be used in the cache to avoid the data inconsistency problem. So in this video, I discussed about what is cache, how it is located, what is principle of locality, and how cache mapping techniques can be implemented, what are the page replacement algorithms, and how the writing policies of cache can be implemented. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.